The title of a project is Design and Implementation of Modified Sepic DC to DC Converter. In this paper, a double boost DC to DC converter is presented. It makes use of a double closed loop controller. The proposed converter in this paper is designed to attain nearly perfect power factor and minimize the total harmonic distortion. The proposed converter in this paper helps us to attain small higher voltage gain even at a smaller duty cycles. The content proposes a simple soft switching technique to remove all the switching losses. In this paper, a modified Sepic converter is proposed. An inductive reactive element is added in series with a switch to boost the voltage gain.
In our proposed converter, we have used 2 switches, 3 diodes, 3 non-coupled inductors, and 4 capacitors. The diodes, switches, and all the components are ideal, and all the capacitors are large enough, and the voltage are assumed to be constant. In mode 1, the switches are turned on, the diodes are reverse bias, 3 inductors and C1 are charging, C2, C3, C4 are discharging during the on state. These are the voltage and the current equations of our proposed converter during mode 1 operation. In mode 2 operation, switches are turned off, the diodes are in forward bias condition, C1 is discharging and C2, C3, C4 are charging during off state. These are the voltage and the current equations of our proposed converter during mode 2.
By using the voltage second balance principle, the average voltage across the inductor is zero. By using that, the voltage across the capacitor is found. For that, the on-state and off-state voltage across the inductor is used. And these are the equations which we obtained while calculating the voltage across the capacitor. And by using that equations, the output voltage gain is found. For that, V naught equal to 1 plus 3D minus 2D square divided by 1 minus GD whole square into Vn. This is the output voltage equation which we obtained. And the DCM mode of operation. This is the waveform of, during the DCM.
The first two modes are similar to CCM mode. In mode 1, the time varies from 0 to D1, and for mode 2, it varies from 0 to D2. During mode 3, all the switches and diodes are blocked. The inductors and the capacitor is designed based on the values of current and voltage ripple. The voltage across the diodes and the switches are given by the following equations by using the mode 1 and mode 2. The current flowing through the diodes and the switches are given below by using the mode 1 and mode 2 equations.
Comparative analysis. It compares the properties of the proposed topology with those of the double boost converter, Sepic and modified Sepic converters, non-coupled inductor, Sepic based converter. This shows that the voltage gain of the proposed converter is greater than all other converters compared. The proposed converter has the highest voltage gain and the lowest voltage stress than other converters. Also, the proposed converter uses more number of components than the other converters under comparison. These are the simulation parameters which we have used. The open loop simulation results are shown below, and it is run using the MATLAB Simulink. Here we have used the PI controller. It helps us to control the output voltage by tuning the KP and KA values of the controller. This is the closed loop simulation. This is the simulation result we have obtained by running the MATLAB Simulink. Source voltage variation is done by varying the input voltage sources. By means of varying the source voltage, we have obtained the simulation results. Here we have varied the reference voltage and the simulation results are obtained. By varying the load power, we have obtained the load simulation results.
These are the hardware specifications which we used while designing our proposed converter topology. And this is the driver circuit, and the power circuit is also shown here. By means of using the Arduino, we generated the PWM signal. And these are the waveforms which we obtained while doing our experimental setup. These are the references which we learned while doing our literature survey. Thank you.